Okay, this lesson is called Counting Atoms. I believe we are on Wednesday, February the 10th. This is the morning, and this is a very important lesson. You must be able to distinguish or understand all the concepts taught today to move forward. First of all, is recognizing what an atom is versus a molecule. An atom is the simplest form, or an element is the simplest form. So what I mean by that is most elements on the periodic table are monatomic, but some of them are diatomic. What makes this an element versus a molecule? It's because hydrogen doesn't exist as just H. It is the simplest form. Just like the simplest form of phosphorus is P4. We don't focus on that in grade 11. We focus on monatomics and diatomics, but elements are either monatomic or they're diatomic. So if you see one type of capital letter, you have an element. If you have more than one type of capital letter, you now have a molecule. Because what this means is you have more than one type of element when you have more than one type of capital letter. I'm going to show you the diatomic elements now. So the following always have a 2 after them. It'll be H2, N2, O2, F2, and Cl2. I always tell students to write that down in their periodic table, to put a little 2, a little 2, a little 2, a little 2, and a little 2. Br and I are sometimes diatomic, but not always. I'll try and make that clear when necessary. So one thing you have to be able to do is to pick out how many elements there are. So if I go through here, I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. I count my capital letters. The other thing people do is every time you come to a capital letter, you put a line before it. Just another technique to help you count. So 1, 2, 3, 4, 5, 6, 7, 8. All we're practicing here is looking at molecules, and these aren't actual molecules, and being able to decipher how many and what types of elements we have in it. I'm going to give you a second and see if you can do the next one. Okay, I believe there's 10. Okay, so every time I hit a capital letter, I'm going to underline that capital letter. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I've got 10 there. The next thing you have to be able to do is when you have a molecule is you have to be able to understand what the numbers mean. This is called a coefficient. Coefficient means to cooperate, and it goes with everything. So if you wanted to count how many you had, you'd have 2 CAs and you'd also have 2 CLs. But this is called a subscript. It only goes with what it's immediately beside. So when you're counting, CAs would be 2 times 1 equals 2. And your CLs would be 2 times 2 equals 4. So you multiply those two numbers together. You're going to have to be able to count as we go through and we do balancing, which is coming up shortly. Let's take a look at what all these numbers mean. The 3 goes with the Mg, the 3 goes with the N, the 3 goes with the O. This 3 only goes with the O. What happens if you have a subscript outside of brackets? It goes with everything inside of the brackets. So mg's, if we wanted to count them, would be 3. N would be 3 times 2. And O would be 3 times 3 times 2. So we're always multiplying the numbers. Let's try drawing it to see what it looks like. So what would 3H2O look like? There's an H2O. there's an H2O, and there's an H2O. So you've got 1, 2, 3 H2Os. So let's do this now. How many H's do we have? We have 3 times 2. How many O's do we have? We have 3. So if you take a look at the diagram here, we can either draw things out to get our answers, or we can just do the math to get our answers. In the first part of the morning, this is your job. You've got 1, 2, 3, 4, 5 molecules to do. See if you can count the atoms on all of those molecules. Part 2 of the morning session will be coming up shortly.